Okay, so yes, I can. Okay, so sorry for the disturbance due to this internet issues. So I will start over again. So good evening, everyone, and welcome to the week 12th live session of NPTEL course on non-conventional energy resources. This course is taught by Professor Prathap Haridoss from IIT Madras, and I will be taking the live session for the week 12th content of this course today. So, as my introduction, I am Lalit Bharti. I am a Prime Minister's Research to the Department of Physics at IIT Kharagpur. So basically, on week 12, we will be broadly discussing few topics. So we will be discussing supercapacitors, flywheels, and magneto hydrodynamic energy generation. So we will be discussing these three broad topics, and also we will discuss this previous week or week 11 with questions. So this is the plan for today. So we start from the ungraded questions which are available from in your NPTEL link or NPTEL website for this course. So this course starts from this question start from magnetohydrodynamic power generation uses the plasma state of matter. So we need to understand, is it true or false? So we need to see that how a magnetohydrodynamics power generation work. So at your right side, we have given two images. So A is your turbo generator, which generates electricity by rotating a shaft. This is your shaft. So by rotating this shaft, and in the opposite of that, at the below image B, that is the image for magnetohydrodynamic generator. So here you can see there is a source. This is a hot source, and it is the source of electrically conducting gas, or it is also, you can say, it is a plasma. So this is a source, and this plasma is going through a magnetic field. So these are the magnets, and then north pole, south pole. These are the magnets. So in this magnetic separation, separation of charges happens here due to this. So we follow Faraday's law here. So this law says if you have some magnetic field and some ion conducting plasma, through this magnetic field, so it will give you the separation of electrical ions. Sorry. Okay. So this Faraday's law states how these ions or these electrical charges separated in the presence of magnetic field. So here the magnetic field is in this direction, and your plasma direction is this. This is the direction of your plasma. Your magnetic field direction is here, N2S. So in perpendicular to both plasma direction and magnetic field direction, you got a electric charge separation in this direction. So these two electrodes are then connected to your external circuit, and the current is flowing through this anode and cathode. So due to this plasma and in the presence of magnetic field, you get a electromotive force generated. So this is basically the fundamental mechanism of magnetohydrodynamics. So this statement is true that we use the plasma state of gas here. So what is the plasma state of gas? It is basically ionized gas. Plasma state of matter is ionized. So this statement is true. Then we will see the next question. The next question says the capacitor store energy using ions. So here it is shown working mechanism of a capacitor. So this is basically a conventional capacitor. But in capacitor, we know that the energy is stored as by using or as separation of charges, not ions. So these ions are used in supercapacitor, not in capacitor. So this statement is false. That these are ions here only. So these are electrical charges only, not the ions. Then we move to the next question. It is so this is the question from your fuel cells. So gas diffusion layers enables reactants from channel area to reach the land areas. So gas diffusion layers are known to provide paths. So they will provide the path to gas to be diffused and to reach up to the electrodes, either cathode or anode. So cathode and anode in presence of electrolytes. So they will produce or generate electricity there. So gas diffusion layer works as path or channels for gas. So this statement is true. That's correct. Then we have the next question. It is on the flywheels. So flywheels, and this flywheel mechanism is shown here. This is your conventional flywheel. Basically, there is a big or the heavy rotor. This is a heavy rotor, and it is kept between this magnetic bearing. This magnetic bearing avoid or reduces the friction while rotating the rotor. And vacuum pumps, it is used to vacuum this chamber to minimize air friction. So if we have air inside the chamber, so it will be producing friction by interacting during the rotor's rotation. So we need to minimize that. So vacuum pump is used, and then is the motor is there, and motor or generator is there. So when we have the additional power, extra power, additional, so the motor will be used to rotate the rotor, and when we need to produce energy, this generator will be used to generate electricity by rotation from this heavy rotor. So the question is, energy stored in a flywheel increases as the cube of angular velocity. So we need to see. So typical or the relation between energy and angular momentum, angular velocity is E is given to be half iota omega square, half I omega square, where half moment of inertia. You can also write down this I as MR. So this is relation between energy and omega square or the omega. This is the angular velocity. It is shown that E depends on the angular velocity square or power 2. This statement is incorrect that because it is not the cube. Then we'll go to the next question. So here the question says a flywheel has a moment of inertia tripled and its angular velocity doubled. So what will be the increase in the energy by which factor? So it is given that your moment of inertia or I goes to 3I and your omega or angular velocity goes to 2 omega. So your E proportional to I omega square. So E will be, after putting this 3I 2 omega square, it will be 12 I omega square. And this is your initial. So your E, now your new E proportional to 12 times initial. So that is your 12 is your correct option. Now next, these are the previous year's question. So these are also important for your main exam as well as for understanding the concept of this course content. So the question is, batteries and supercapacitor are identical in performance characteristics. This is a supercapacitor and this is battery. Yes, both are the electrochemical or both are the energy storage devices, but they have differences in performance characteristics. So supercapacitor is basically a high power device, and batteries are or you can say the power density, high energy density. So supercapacitors are used when you need instant energy. So whenever you need the instant energy or your demand is very high at a very small time period, then you need supercapacitor, and batteries are used for or you can say the longer supply. So these are basically opposite in terms of performance. So one has the high power density, and other is high energy density, but power density is lower. Here energy density is. So that statement is false, that they are identical. So now we take the second question. So second question is statements the use of regenerative braking in electric vehicles is based on what? So basically, what is regenerative braking? So whenever you apply brakes on a running car, let's say it is running in this direction, and you apply brakes here. So this energy or this kinetic energy of this electric or this moving vehicle or the rotating wheels, they will be transferred or transformed in the electrical energy. So your while braking, your mechanical energy from wheels, it will generate the electrical energy. So there will be basically a generator in between. So whenever you apply the brake, instead of just using traditional disc brakes, which will be just heating it up, and this energy will be lost in form of heat. So instead we use this and we convert it this kinetic energy in electrical energy in motor. So it is again stored back to the EV main battery pack. So we need to understand what are these four options. So first is brake pads are removed after each day and attached to this battery for electricity generations. So no, the brake pads are not removed. Brake pads are always there, and it is not generated by the brake pads. It is generated by a flywheel which is connected with this braking system. Whenever you gently press the brake, this whole the kinetic energy of your rotating wheels, it will be transferred to the flywheel. So your rotating wheels will lose energy, so you will speed down, but the flywheel gain the energy and it will convert the energy by a generator in electrical energy. So this statement is incorrect. Second option is braking action rotates the rotor of a generator in the car. So that is correct. That braking action, it is attached with the rotor of a generator. Then third option is braking generating heat during operation. This heat is converted to electricity. So heat is not converted. The heat is not converted. Fourth is rechargeable batteries in the car are able to accept electricity generated in the car. So yes, whatever your battery, your electricity is generated, it will be transferred to the rechargeable batteries inside the car. So these option 2 and option 4 are correct. Now we'll see the next question. So this is third question. It says, what are the major replacements done in a conventional capacitor to convert into a supercapacitor? So this is a conventional capacitor. And this is your supercapacitor. So what you need to need to replace. So first we need to replace these dielectric by ions. So dielectric by electrolyte. So what it will do, in dielectric the charge is stored, or in a capacitor charge is stored in the form of sorry, in the capacitor, the energy is stored in the form of charges, and here it is stored by the movement of ions in supercapacitor. So we need to replace the electrons by ions. This dielectric by electrolyte. So the option first and option second, this 1, 2 are correct. Then static charge induced by dynamics motion of the charge carriers. Static charges induced by the dynamic motion of charge carriers. So charge carriers are basically ions. So here static charge means this charge which is generated inside. So this charge will be replaced by the moving or dynamic charges, dynamic ions or charge carriers. So this also correct. The fourth is flat contact surface by non-flat contact surface. So this is your flat contact surface. Okay. So if you have a cross section of A and you have a length and width of A, so your total area will be contact surface area will be A by A. But here in supercapacitors, our surface area is much higher than your just your A square, because the surface or the material is such that the porosity is very high. So surface area is very high. So we need to replace the just flat surface by a non-flat contact surface. So that is also correct. So this was the fourth question. Now we'll go for the next one. Next is, if two energy storage devices have distinctly different specific energies. So specific energies. So what will be changed? So first option is the device with higher specific energy has, so let's say here higher, here lower specific energies. So if your energy is higher, your capacities will be higher. Capacity of that system is higher, so capacity will be higher. First option is device has a higher specific power. So power is not required to be higher if your energy density is higher. So power do not have any relation with energy densities. So your option 1 will not be correct. Second is the device with higher specific energy has low specific power. So power, since power do not have any relation, it will not be lower or higher. Third is specific energy and specific power don't necessarily have the same trend across devices. So that is the correct, because they do not directly relate with each other. It can be higher or lower, but they do not directly relate. And the fourth option is the device with higher specific energy will store more energy for the same weight. So we are seeing, we are looking here that with higher specific energy, capacity is higher. If capacity is higher, higher storage of energy. So this statement is also correct. Then we will look for the sixth question. This question says, in general, there are 4 gears. This is your 4 gears, and it's simplest flywheel setup. If the size of gear G1 is smaller than G2, This is your G1, this is your G2. So G1 is smaller than G2, and your G4, okay, so between G1 and G2 we will discuss first. So G2 will move at the same RPM as G1. So definitely they will not be same. They will be either higher or lower. Here also we can compare this driving gears and driven gear and driving gear. So if you are providing energy of rotation to this driving gear, so it will drive this driven gear. So if they are equal in size or they have equal radius, so their speeds and torque will be similar. But if you go for driving gear to be higher and your driven gear to be lower, your speeds will increase, but as well your torque will decrease. Similarly, if you go from smaller driving gear to larger driven gear, your torque will increase, but your speed will decrease. So let's say here, it is obviously not the same. G2 will move at lower RPM than G1 because your G2 is larger in size, their RPM will be lower. So this is your size, your RPM for G1. G2 is lower and G1 is higher. So you can understand from this figure also. So that is correct. Then G2 will move higher RPM than G1. That is obviously incorrect because the previous one is correct. G2 will move at lower RPM than G1. So you can say that again the size difference. So this is your G4. G4 is quite smaller than G2. This is the size of G2 and this is the size of G4. It is smaller. So again the RPM of G2 will be G2 will be again lower. Here also it is lower. Option 4 is also. Then we'll see the next question. So we have this energy stored in a flywheel of radius r rotating with velocity v proportional to what? So we need to find out this energy. So we have already seen this energy is basically half I omega square. Your omega is your angular frequency, angular velocity. And I is your momentum of inertia. Okay, so you can write this I as m for cylinder for a cylinder. Cylinder means your rotor shape is in cylindrical shape, so it will be 1/4 mr square omega square, because for cylinder I is equal to half mr square. So this will be your final relation. So the question asks square of the angular velocity, cube of the angular velocity, square root of angular velocity. raised to the power 0. So we can directly see the E is angular velocity to the power 2. So only the first option is correct, rest are incorrect. Now we'll see the next question. Next is your, again based on your MHD or magnetohydrodynamic based electricity or energy generation, is typically used in association with what? Thermal, wind, OTEC, or flywheel. So basically, clearly it is not the OTEC, because OTEC works in the under the sea with the temperature difference of different depth of seawater. So that is all clearly incorrect. A flywheel based on regenerative braking system. So regenerative braking system is used in EV. So clearly it is not correct, because this MHD system is not a mechanical system. Wind-based power plant, it is also incorrect, because this is not a mechanical system. We don't see any use of wind power here. Thermal power plant. So because this plasma is at very high temperatures, so this source is at high temperature, and after the plasma, after the separation of the charges, this remaining plasma beam is again at very high temperature. So this high temperature can be used as a source for thermal power plant. You can either use it to generate steam from a water source that can generate steam, and the steam can drive a generator, electrical generator. So you can get electricity from there. So your first option is correct. Then we'll see the next question. Next, we need to match the following. So 1.2 atomic number 19 and 16,000 RPM. So we have flywheel, water, and seeding material. So basically, if this is the RPM, means it is related to rotation, and rotation means it is flywheel. So your flywheel is first. So if it is the rotation, only the flywheel have the rotation of rotor. So that is why it is called flywheel. So that is the option C. For A, we will have 1.2 watt for water, because water have this water splitting at 1.23 volt. So generally, or simply, the H2O will this H2O will split in hydrogen and oxygen at 1.23 volt. So this reaction will go to water. And atomic number 19 is the for the seeding material. So if you see the seeding material for MHD system, these are basically either potassium or cesium. And if you remember the atomic numbers, potassium have atomic number 19, cesium have 55. So your B will go to a seeding material. We'll see second, third, and first. Your option second, third, and first. Option fourth is correct. Okay. So now we have this previous or week 10 problems. So these are the graded quiz questions. we will see these questions and we will discuss this. So we have quite time, so we'll take a rest or take a break of 5 minutes. Then we will get back to these questions. Okay, so we are back to our discussion. So basically, this is the question first from week 10. Oh, sorry, week 11. So this is your week 12. So this is Question first, it says the gas flow rate, humidity, temperature, and gas purity are some of the parameters controlled for testing a fuel cell. So it is for the test. This is basically a fuel cell, and if you need to test, because we give the input as O2 and H2. These are both two inputs. So if you need to test this system for real life application, so you have to control and you need to analyze the performance of these fuel cells at different conditions, like different type of purity or and flow rate. Humidity means the water content, the temperature. This is the ambient temperature. These are from the gas in this input gas. So you have to control this time, this all these parameters. Then you have to characterize and test your system, test your fuel cells for these various parameters. So this statement is true, that yes, we need to control these parameters for testing of our fuel cell. Then we have the next question. It says the fuel cell setup used in the lab for lifetime testing and real operational can differ in terms of what? So if you have a fuel cell and you are testing it for the real life application, so this is your lab condition, this is your real life condition. So what will be the difference? Obviously in lab you have bottled air with controlled quality. But here you have the you don't have the bottled air. This is the ambient air, and you can't exactly control the quality. So you can use some filters, but the quality will not be the very much controlled or very much pure like a bottled air. So this option is correct. Yes, we need to consider that. The option second is rapid changes in operating conditions. So yes, that will also be changed. Operating conditions are different for both lab and real life system. So your temperatures can be different, your humidity and purity of gas. So this kind of parameters can be different for these lab and real life conditions. It is also correct. Then we have reversal of anode and cathode. So that is not correct, because in real life or in lab the anode will be at the same place and cathode will be at the same place. We will not change the structure, internal structure of the system. We will just keep the same for lab and real life. Use of hydrogen at the cathode. So that will also be not be changed, because the hydrogen will be at the cathode and oxygen will be at the anode, whether it is in the lab or in the real life. So option 1 and 2 is correct. These both two options are correct. Then we have third question. It says that with respect of the gas used in fuel cell in the anode of PM fuel cell, which of the following are usually true? So this is basically a PEM or proton exchange membrane type fuel cell. So the first option, the gas is dry in order to prevent the catalyst from dissolving. So that is not correct because we already have this catalyst here. It will not dissolve in the air. We don't want to dissolve this. We don't want to prevent the dissolving of that catalyst. And this electrolyte, it can be a aqueous electrolyte, and we have H2O at the end. H2O. So we need to keep this gas humid to keep the electrode and membrane humidifier. Okay, so we want to react this H2 and O2 to make H2O. So the option 1 is incorrect, but the second option is correct. The gas is used is usually high purity hydrogen. That is correct. Yes, we use very high purity hydrogen. We pure these gases by various stages of purification. For this, gas use is usually vaporized petrol. That is totally incorrect because we don't use petrol. We use only H2 and O2 as input gases. So option second and third are correct. Then which is the question? This is the which gas will lead to poisoning of fuel cell? We have four options. So instead of hydrogen, we'll be using what which will be act as a poison for these fuels. So obviously hydrogen is not the case. Neither nitrogen, because nitrogen will not drastically react with other gases. CO2 will also be not be, but CO, if we use CO with the reacting with oxygen, it will provide some CO2, and which is very harmful for our fuel cell. So that is correct. The CO. These were the fourth question. Then we will see the fifth question. So fifth is we need to match the columns with fuel cell and internal combustion engine. So the columns are gases are mixed directly. So first we need to see this is the internal combustion engine, and we have already discussed this fuel cell. So in fuel cell, your oxygen comes in one place and hydrogen come at one place, and you get H2O and some electricity additionally. But in the internal combustion engine, you have a mixture of gases. So you have fuel plus your air, which basically have oxygen. So it will go inside the piston chamber, they will be ignited, they will be burned, and at the exhaust we will be getting some CO2 and some other gases. So gases are mixed directly. This is clearly a function of internal combustion engine. The second is H2 plus air, H2 plus O2. So H2 plus air is not correct for either of the options. H2 plus O2 is in the fuel cell. Yes. Then gases are mixed, not mixed directly. So that is also fit fuel cell. So A has your third, your fourth, This is fuel cell is a electrochemical correction process. So we have 5, and 6 is basically simply the internal combustion engine. B is having your 5, 6, and first. So if we just look at the options, your second and fifth, this is correct. This is third and so even the third is B is fifth. So B is not fifth, so that is incorrect because this B is not fifth. A is 4 and B is 6. So A is 4 and B is 6. That is correct. A is 5 and B is 1. A is 5 and B is 1. That is also correct. A is 6 and B is 2. So it is B is not 2 and A is not 6. So that is also incorrect. So your option second, your second and third options are correct. Now we'll see the next question. It is to increase the efficiency of a fuel cell. What we need to do, so increase the surface area of catalyst. So that is correct because if we have, this is the surface area of catalyst where your H2 is changing, is converting into H plus and electrons. Similarly, in this area, in this region, your 2H plus will react with hydrogen, with oxygen and with electrons. So you get a H2S product. So this catalyst and its surface area is quite prominent requirement for this fuel cell functioning. So the option one first is correct. Second is increase the three-phase region. So what is the three-phase region? This is your three-phase region. So basically you have cathode here, anode here, and your electrolyte here. So by including all these three, this is called three-phase system. So if you increase the area, this area, their reaction will be higher, and this efficiency will be also be higher. So this area is also, this option is also correct to increase, for increasing the efficiency of fuel cell. Replace the polymer electrolyte with the polyethylene membrane. So that is not the correct. We don't need to put plastic membranes. It will not increase the efficiencies. Using platinum rod instead of perforated platinum. So this is about the catalyst. So this will not change because it will still be a platinum. It will not change the efficiencies. So the efficiency will be increased by both two options, by the surface area catalyst and three-phase region. So this was the option. This was the question 6. Now we are taking this question 7. This question says, consider a case of solid oxide fuel cells, which is shown here. Solid oxide fuel cell. Where we replace a metal wire used in the external circuit powered by the fuel cell with a semiconductor wire. So your metal goes to semiconductor. This is your external wire. So what will the possible changes? So first change will be the conductivity, so the electrical conductivity of metal. So it will be decreased because metals have high electrical conductivity than semiconductors. So first option is everything will be all right except the fuel cell operation temperature. So because it doesn't depend on the temperature, so it will not be affected. Ionic conduction will increase at rapid rate, so it will not increase, and it doesn't. The external circuit, the material of external circuit, it will not affect this ion conductivity. Only the ion conductivity is inside the fuel cell. It will not be affected by the external circuit. Then we have electronic conduction in the outer circuit will be affected. That is will be definitely will be affected because the electrical conductivities are reduced now. So more energy will be wasted because overall efficiency will degrade, will be downward. So yes, the option 3 and 4 correct. Now we'll see the question 8. It says electrolyte used in fuel cell and lithium batteries are same or different. So basically in electrolytes in batteries, these are not same. We use some lithium based electrolytes in the batteries, lithium ion batteries, because it required to be lithium based salt. But in electrolyte in fuel cells, it is these are alkaline electrolyte. They don't require to be having lithium or some specific element. So usually a typical example is KOH. So that is used in fuel cell, but not used in lithium ion batteries. So these are lithium based salt in organic solvent. These are typically used in present industrial lithium ion cells. It is different, and they both are ionic conductors. Yeah, that is correct because it will also conduct ions here in fuel cell and is similarly in the lithium battery. So here lithium plus will be lithium plus will be transferring. This is also, and in the fuel cell it will be potassium plus or OH minus. So that is same for both systems. But the electronic conductors, they are not electronic conductors. They are only ionic conductors. So again, options 2 and option 3 are correct. Then we have this 9th question. It says, which helps in cold start because it, you have to see the options. So basically in fuel cells, for a cold temperature, the preferred is proton exchange membrane because this membrane helps able to operate at low temperatures. The proton exchange membrane, because it operates at low temperature, gives water as a byproduct which accelerate the product. That is not correct. It doesn't. Membrane will never give a byproduct as water. Then solid oxide fuel cells helps in cold because, so they're not, because solid oxide fuel cells works at very high temperature. It is around 1000 or higher. So that is not correct. Again, that is not correct. Only first option is correct. Then we have the last question, 10th. It says for the efficiency working of fuel cell, CO or carbon monoxide must be, which can be partially achieved by what? So for a fuel cell, your input gases should be very pure. So it should be always lower than 50 ppm, because 50% is a very high number. So if you have 50% CO, then it will be poisonous for the fuel cell system. So it will be lower than 50 ppm. So we can have multiple methods. We can use multiple methods to purify the gas. So we can use water gas shift also, as well as the preferential oxidation reaction. So which will simply using the oxygen reaction with oxygen at some temperatures, it will oxidize and will separate, take it out. So that will be called preferential oxidation reaction. So both are correct, and both these options are incorrect. So option third and fourth are correct. So this was. So basically we are done with this today's part. So this is your week 12. So this is your last NPTEL or last session, live session for this course. This is this week 12. So the time is still remaining. So I am here if you have any of you have any queries. Otherwise, you can write to me, or you can, this video is available on YouTube, so you can comment it there. So I will solve that. I will try to solve that query there. So we have basically completed today's session, and this time is for any questions or any queries. So this will be probably your last discussion for this course, and your exams, your evaluation exam will be after after this week, I guess. So if
Yes,
anyone
sir.
have any, okay. So if you have any queries regarding this course or this content I taught today or earlier, so you can ask for now. So this will be an online exam or any offline exam?
Sir, it's on online exam.
Online exam. Okay, okay.
Sir,
Sir,
what
give
should prefer
IMP for
for
exam.
exam?
Sorry.
IMP, sir.
What should prefer for exam, sir, for getting best score?
So basically, the questions like we have done previous year's quiz questions, and all the questions are also available as your assignments in your main NPTEL course. So your exams questions will also be similar to these assignment questions. Okay, so if you solve all these assignment questions and all previous year assignment questions, like which are solved in your tutorials, this discussion which are available on YouTube. So if you come, at least
sir.
you cover all these questions and at least just read the content once, so that will be enough to get the best score.
Okay, sir. And sir, what are the percentage of multiple choice question or single choice question?
So
Means
I don't know.
what is the exam pattern, sir?
I think this exam pattern is MSQ, like multiple selection question, but
Sir,
I guess they will give you the clear instructions. Either already they have mentioned on the website, otherwise they will give you clear mention that how much the time will be given, what will be the number of questions, what will be the marking scheme. So they will give you the proper instructions so that you don't
yes.
need to worry. But the question will be similar to your assignment questions. So in assignments, all are basically the multiple choice question. So in
Yeah, sir.
exams also you expect these multiple choice questions. Yes.
Okay, sir. Thank you so much, sir.